Section 2.3, homework number 1. Use a math join to explain why multiplying the numerator and denominator by the same number results in an equivalent fraction. So first we must have a math join, and we're going to use the join to explain whenever we have a fraction, any kind of fraction, and if we multiply the top and the bottom by the same number. In your problem, you're multiplying by 3. In my example, I'm multiplying by 5. And after we multiply both the numerator and denominator by the same number, and we always end up with an equivalent fraction. So that's the first thing we want to do. And students may find it confusing that we are multiplying the number, yet we divide the parts in the math join. Okay, so there are two separate things here. Numerically, we are multiplying a number, so whether it's multiplying by 3 or 5 or any number, 7, 4, 9, and we are doing multiplication numerically in this fraction. But when you look at the join, so every step we do numerically, we can show that in the join. But in the join, notice that we are actually dividing each part into smaller parts. So for example, we divide this part into 1, 2, 3, 4, 5 equal parts, because my example is multiplying by 5. In your case, you have to draw your own paper strips. And so we are actually, we're multiplying by 5. Oops, that's too dark. So we're multiplying by 5, but we actually divided this part into 5 equal parts. So some students might be confused that, well, you're multiplying and then you divide, but you're multiplying a number, but you're dividing the join, okay? And so maybe if it confuses them, maybe use the word like a cut or something. I mean, technically cut is dividing. Okay, so attend carefully to this point and to the number and the size of parts. So although numerically we do multiplication, we actually cut the bigger part into many smaller parts. I mean, it kind of, if you explain to them the number of parts, because when you multiply by 5, yes, the number of parts will be increased by 5 times. I mean, so because if you want to get 5 times as many parts, you have to subdivide, right? Okay, so let's look at the example and use the example to explain the whole thing. All right, so first of all, I have the drawing here. So you will have to draw 2 identical paper strips. So the top one, the bottom one here. And the top one, we use it for the first fraction given 3/4. So recall the definition of 3/4. That means you divide the whole into 4 equal parts, 1, 2, 3, 4. And then top means 3 parts, so you will shade 3 parts, 1, 2, 3 here. Okay, and I guess in this case the size of each one they did right here. So this is right here. They put a definition here. If you want, you can also do that, and helps you understand, you and also your students understand the problem. So it's a little very tiny, small here. So it says, okay, 3 equal parts. Definition of 3/4, 3/4, 3 equal parts, each of size 1/4. All right, now let's see numerically. Let's multiply the top 3 by 5 and the bottom 4 by 5. So what does multiplying of 5 do to the join? So what it does is it's going to, because we need to turn, instead of dividing the one whole paper strip, the entire paper strip from here all the way to here into 3 equal parts, we take the second one and divide. We have to get 20 equal size. Well, if we already have those cuts, so these cuts were already made. So again, imagine that there was a cake. When you bought a cake, it was already cut into 4 equal slices. But then we found out there are going to be, instead of 4 people sharing the cake, we're going to have 20 people sharing the cake. So that means you have to cut each slice into 5 equal parts. That way, 1 5, 2 5, 3 5, 4 5s, that will give you a total of 20 equal slices that can be shared equally among 20 people. So that's why times by 5 means you're going to get 20 equal parts. But if you already have 4 cuts, 4 slices, you will have to just cut each slice. Let's take the first slice and cut into 1, 2, 3, 4, 5 equal parts. And then you're going to take the second slice and do the same, and third slice, do the same, and the last slice, do the same. Okay, so now the original cake, instead of being cut into 4 slices, now it's cut into 20 slices. Again, you would be thinking this way: 1 5, 2 5s, 3 5s, and 4 5s. So 4 times 5, which corresponds to the bottom number. And now let's look at the shaded part. So let's say the shaded part is what you got to share with your friends. So you got 3 slices originally, but you realize you have to share with 15 friends altogether. So you're gonna for your 3 slices, you of course you did the same thing already. You cut them into 5, each of them into 5 equal parts. So now you have 1 5 and 2 5s and 3 5s, which is 15, which is the top number and your share. Okay, so the bottom number is out of the whole. How many parts for the whole cake? The top is your share. Okay, all right. But again, because we suddenly for example, originally you thought you only have to share with 3 people. Now you realize you actually have to share with 15 people. So you have multiplied by 5. And so originally 4 slices. Maybe this is your brother's share, and then originally he was just gonna eat this slice, but then he realized he has to share with another 4 people, so he has to divide that piece also into 5 equal parts. Okay, so that's using, you can use cakes, pie, probably cakes, and ribbon or a rod to explain. So what I said here, you divide a rod into 4 equal parts. So that's explaining the first paper strip into 4 equal parts, 1, 2, 3, 4, and shade 3 parts, which is your share. 4 equal parts, that's the whole whole cake or whole rod. Okay, so now deal with the modification, multiplying by 5. So you always start with 3/4. Then explain what times 5 and do to the drawing. So if we divide each of the 4 parts into 5 smaller parts, each of your share, I'm sorry, actually the entire cake, 1, 2, 3, 4, each of them is turned into 5 equal parts. And the shaded part will now consist of 3 5s, 1 5, 2 5, 3 5s, small parts, and the whole cake will be turned into 4 5s of smaller parts. Okay, so again, that's your share, and that's the entire cake. And thus, the shaded part of the rod can be described both as fraction 3/4 and also as 15/20 of the rod. Or if you don't like the word rod, you can use a cake to explain. So again, why these 2 fractions? So here we explained why these 2 fractions are equal. 3/4 equals 15/20. That's because when you have 1, 2, 3 out of the 4, and which is the shaded part, is turned into, again, 1 5, 2 5, and 3 5s. So that is 15 out of the total of 4 5s, 20. So 15 out of 20. Notice that the 4 parts has, although the size are bigger of each part, is exact the same. The total of 4 parts is exact the same as the size of 20 slices, smaller slices. And also the 3 slices, your share, now is turned into 15 slices, but the total size from for these 3 bigger parts is the same as the 15 smaller slices. So your share out of the entire cake is exact the same. It didn't change. it just turned into more slices or smaller slices. Okay, so therefore they represent the same number. And to answer that question, the second part here, attend to the number and the sizes of the part. So notice that when you look at the sizes, originally it's 4 big slices, but now you have 20 smaller slices, and your share of 3 big slices are turning into 15 small slices. So I have to say that when we multiply both numerator and denominator by the same number, results in dividing the bigger parts into the smaller parts. And also the number of the number of parts is larger, but the size is smaller. I should add a sentence here. And the size of each part is smaller. So we have more slices or more number of parts, but the size of each one, see, look, this is the size of each one now compared to that one is much smaller.